Go. Notes number 2 for chapter 11, area trapezoid, rhomboid, and kites, page 56 through 57. Okay, the first theorem is 11.4 is the area of a trapezoid. A trapezoid is half the product of the height and the sum of the base and the lengths. So if you have a picture, you have a trapezoid. This would be base 1, base 2. Your height has to be the perpendicular to be the height, so that you know all the shapes that you have to have for your picture for that, so that you'll have your formula right there. That's a very, very important formula. Another way of seeing that, by the way, would be area equals height parentheses base 1 plus base 2 all divided by 2 would be an alternate way of seeing that formula. On theorem 11.5 is the area of a rhombus. The area of the rhombus, once again, is half the product of the length of the diagonals. So if you have a diagonal or a rhombus, remember on a rhombus all sides are equal. Your diagonals, you have the first diagonal would be D1, and then if you had the other diagonal, that would be D2. So you'd multiply your two diagonals and then divide it by 2. So the alternate formula would be D1 times D2 all divided by 2. Okay. Theorem 11.6 is dealing with the kite. Here it's 1/2 the product of the diagonals, just like the previous one, but this time the shape is a kite. Okay, remember on a kite, two sides are congruent. The diagonals, that would be like D1, and then the other diagonal going all the way down the center would be D2. So you would find those two lengths and multiply them together and divide by 2. So your alternate formula is just like the rhombus, D1 times D2 divided by 2. Okay, if I look at the first example, I forgot to put example on here. So example 1, this is a trapezoid. So that means that this is base 1, top one is base 2, and this one is the height. So your formula that I'm going to use is height and times base 1 plus base 2 all divided by 2. So if I fill in my numbers, this would be 8.8 parentheses 16 plus 10.2 all divided by 2. I'll grab my calculator. I'm going to put the top in first. 8.8 parentheses 16 plus 10.2. I'll put that all in my calculator, and I have 230.56 divided by 2. When I divide by 2, I come out with the area equal to 115.28. and do I have any units? No, no units, so that would be units squared for my answer. Okay. Example 2 is a rhombus, or actually this is a kite. With the formula for your kite, that was D1 times D2 divided by 2. So if I'm looking at that, notice the 7.5 is referring to this first diagonal, and then the 16 is referring to the second diagonal in my picture. So that means to actually work the problem, I'm going to fill in my values. So I'm going to let this first one be diagonal 1 and this one be diagonal 2, which means I'll have 7.5 times 16, and I'll divide by 2. 7.5 times 16 is 120. I divide that by 2. Excuse me. That gives me 60, and there's not any units, so that would be units squared would be the area for the kite. Alright, if I look at example 3, this one is a rhombus. The formula for the rhombus is area equals D1 times D2 divided by 2. Same formula. If I look at my picture, I have one diagonal. It says part of it is 2.7, so it means the other half is also 2.7. I'm going to label this one my D1, so that means D1 is going to be 2.7 plus 2.7, or you could do 2 times 2.7. Regardless, this gives you 5.4 as your first diagonal. Okay. If I go the other direction, the bottom is 1.4. That means this top section here is also 1.4. I'm going to label this one my D2. That means D2 is going to be 1.4 plus 1.4, which is 2.8 is my second diagonal. Since I know that information, that means I can now plug them into my formula. D1 is 5.4 times 2.8, then divide by 2. 5.4 times 2.8 comes out to be 15.12. If I divide that by 2, I end up with 7.56, and I don't have any units, so that would be units squared for my answer. Okay, on page 57 now, example number 4, we're looking for the value of x. If we're looking at our picture, it has the first diagonal. I'm going to do the horizontal one straight across. I'm going to let that one be D1 because it's 5 plus 5, so that means D1 is equal to 10 meters. And realize this is a kite, so the formula that I'm actually referencing is going to be D1 times D2 divided by 2. And, oh, that's supposed to be a D. Looks like a A. D2, if I am looking at the picture, going from the top to the bottom section is 12, and this top section is the X that I'm looking at. So that means D2 is going to be 12 plus X for my expression. If I take this now and plug it in to all parts of my formula, realize I do have a very important information right here that says the area is 80 meters squared. So beside it here, I'm going to put 80 equals, because this is my A, and I'm going to do D1 times D2 divided by 2. D1 was 10 times D2, that was 12 plus X. Okay. If I'm going to solve this, I'm going to put the 80 over 1 so that now I can cross multiply. Two times 80 is 160, and 1 times all of that is just that mess. And from there, I'm going to distribute into the parentheses. 10 times 12 is 120 plus 10 times x, which is just 10x. Now solve for x. That means I'm going to move the 120 and subtract. That gives you 40 is equal to 10x, and And the last step is to divide by 10. That means x is equal to 4. So to answer my question, that means I need my units, which would be 4 meters, is what x equals. And if I go to number 5 in the examples, it says we want to find the area of the shaded region. Notice this is on a coordinate plane that I'm looking at. If I'm trying to identify the shape, this particular shape, notice I have 2 parallel sides, and then I have 2 legs on the other side. Since these lines are vertical, that means they're parallel. That means this is a trapezoid. And my formula for a trapezoid is the height times base 1 plus base 2, all divided by 2. My bases must be the parallel sides. So here will be my base 1, which is 1, 2, 3, 4, 5. And then the other side will be base 2, which is 1, 2, 3. So I've got my B1 and B2. Now I need the H, the height. The height is the perpendicular distance between the bases, so I can pick any one of these lines that goes from top to bottom. Doesn't matter where. I'm going to pick the x-axis. This is going to represent my height. And if I look at it, it is 1, 2, 3, 4 tall. So I have my 3 numbers now. I can plug it into my formula and have my answer. So looking at my formula, the height was 4, base 1 was 5, plus base 2, that was 3, and then I'm going to divide by 2. Okay, 5 plus 3 is 8, and 4 times 8 is 32, divided by 2 means my area is 16 units square. Okay, here's your independent practice number 1. Find the area of the trapezoid. Here's your picture. Once you copy down and work it. Here's your independent practice number 2. I want you to copy it down and work this one. Here's number 3. I want you to copy it down and work number 3. And then there's number 4. I want you to copy it down and work it.